Good day. So I'm going to show you how to find the derivative of a fraction using first principles. So how do we find the derivative of a fraction? Well, the formula for first principles is f prime x is equals to limit as h tends towards 0, then we have f at x plus h all minus f at x all over h. So now we're going to have limit as h tends towards 0. So let's start with the substitution. So this is f at x plus h, meaning that wherever we see x, we have to replace it with x plus h. So we're going to say 2 over x plus h minus, this is the normal equation, f at x, which is equal to that. So that's what we put without any manipulation, all over h. And then from here, limit as h tends towards 0. So the method I'm going to use here with the fractions is a method whereby if we have 2 over 3, let's say, plus 4 over 5, it's called the butterfly method. So whereby you say 3 times 5, you get 15. Then you cross, you just say 2 times 5, which is 10, 4 times 3, which is 12. Another example of that formula, let's say 2/3 minus, let's say, 1/5. So we just multiply the denominator, so that's 15. Then we say 2 times 5, 10, and then we just copy down the minus because it's a minus. And then we're going to say 1 times 3, which is 3. So that's what we do. That's the method I'm going to use. That's the butterfly method. So let's continue. So I'm going to use the butterfly method. So when we multiply this, my advice is not to really multiply them. Just keep them together like this instead. So of course the smaller one will come first, so that's what I did. And then from there I multiplied 2 times x is 2x, then minus 2 times this whole stuff, you have to put it in brackets, so there's a minus, so minus 2 times this whole stuff, right? Minus 2 times this whole stuff, we have to put it in brackets, so it's going to become that, right? Whenever you're multiplying something with more than one term, please put it in brackets like this, and don't rush to the next step. Please start like this. So limit as h tends towards 0. And let's not forget the main denominator, which is h, right? Do not forget it, please. There is a higher chance of making that type of mistake.
Just before I continue, if you want to be tutored, either online or physically, online it doesn't matter where you are or which country you are at, you can still be tutored. So we offer cheap online lessons, and if you want to be tutored physically, we can still make an arrangement. So call or WhatsApp this number, but preferably please WhatsApp this number, and then we will take it from there. So what I do is that I tutor people 5 days a week online, and I give tests once a week so that I can check your improvements.
And then from here, we're just going to distribute that. So we're going to have 2x minus, so 2 times x, which is that, and then we're going to have negative 2h, then all over x into x plus h. So that's what we have. So then this becomes limit as h tends towards 0. So now this of course cancels. Obviously everything that does not have an h will cancel, obviously. So this cancels, and we're going to be left with negative 2h all over x plus h. Okay, x into x plus h all over h. And then this, notice this is a fraction divided by a fraction. We can actually write this as a fraction. The numerator cancels numerator, denominator cancels denominator. So all we'll be left with is limit as h tends towards 0. So as h tends towards 0, we'll be left with minus 2 over x into x plus h, because this h is cancelled. Or if you want to use the tip and times method, let me use the tip and times method. So let me just write it here. So before we were actually left with minus 2h all over x into x plus h, and our main denominator was h, right? Just confirming that. So that's what we had, right? So this is the same as h over 1 still. So if you use the tip and times method, we can rewrite this as, but you don't have to show them this. This is side work. There is no mark for it. But if you want, you are welcome to show them. So remember, tip and times, whenever we have a division line, when we change it to multiplication, we actually have to change it to multiplication and the second denominator changes. For instance, let's just say we have 2 over 3 times divided by 4 over 5. The rule is we change the division sign into multiplication and we switch the second fraction. So the denominator becomes numerator, the numerator becomes the denominator. Or another example is, let's say we have 2 over 3 divided by 4 over 5. So when we say this stuff, we just say 2 over 3, we change the division sign into multiplication and we switch the second fraction. So then we'll have 5 over 4 because we had 2/3 over 4/5. So the division sign changes to multiplication and this switches, just in case you don't know that method, just in case. So we have a fraction divided by a fraction, so this division sign changes into multiplication and this switches. The 1 becomes the numerator and the h becomes the denominator. Then this and this will cancel. Whatever is the same but on different lines cancel, right, according to the rule of multiplication. Then we'll multiply what's left, so minus 2 times 1 is minus 2. Then we'll have over x plus h. And then this, that's we still have to have limit as h tends towards 0. I assume that you guys all know that, right? So we have to have limit as h tends towards 0 in every step, right? Except on the step where we're going to now substitute h as 0. So when I substitute h as 0, we're going to have minus 2 over x into x plus 0, and our final answer will be minus 2 over x squared, because x times x is x squared. Alright, here is another example. Let's just say we've got an equation that says f at x is equals to minus, let's just say minus 1 over x. And of course the formula is f prime x is equals to limit as h tends towards 0. Then we have f at x plus h all over minus f at x all over h. And then here we have limit as h tends towards 0. So this, when we substitute, it's going to be... Alright, I would like to manipulate this question. Let's just say it was x squared. Let me just take it a little bit higher. Let's just say the question was x squared. So then what do we do in this case? So we will say x plus h all squared, because in place of x, I'm substituting with it x plus h. So this is going to be, so that's what I'm substituting in place of this. And then this is going to become minus 1 over x squared. So because there is a negative, I have to put it in brackets so that it can become a double negative, right? Because we have a negative here, we have a negative here, right? So just in case you guys got confused, all I did was in this formula, in place of f at x, what I'm doing is I'm saying limit as h tends towards 0. So in place of f at x plus h, in place of x, I'm putting x plus h. So then it becomes minus 1 over x plus h. But since it was x squared, this becomes all squared. Then minus the original formula. So because it's a double negative, I had to put it in brackets. Then this is all over h. Then what we have here is limit as h tends towards 0. What we're going to have there is minus 1 over x plus h. And then we're going to have what? We're going to have plus 1 over x squared divided by h, because the minus minus becomes plus. Now we use the rules of adding fractions, right? So it's the same rule, the butterfly method. So we're going to just multiply them, so it's just going to become x squared then x plus h all squared. I just mixed them, right? So then this, when you multiply, it becomes minus x squared, because minus 1 times x squared is minus x squared. Then this times that becomes plus x plus h all squared. Then we have the main denominator. So let's go further. So what I'm going to do is to expand this bracket, right? So I'm going to expand the bracket. So let me do so. So let me just rewrite what was left before. So it was minus x squared plus x plus h all squared. Then we had x, okay, let's just do this. So we had x squared, then we had all over h. So limit as h tends towards 0, right? We have to have it. So what do we do here? So let's expand it. So when we expand it, obviously we'll have our final answer. When we expand it, will be x squared plus 2hx plus h squared. So I'm using the shortcut for expanding. And then now I don't need to expand the denominator. There's no need. So we'll have that. Just like I didn't expand it before, right? Or I didn't distribute before, and we cannot distribute whenever there is a squared on the second bracket. For instance, if we have this stuff, you are not allowed to distribute the two inside up until you deal with this bracket. So let's go further. So obviously everything without h will cancel and we'll be left with 2hx plus h squared all over x squared plus, okay, x squared into x plus h all squared. And then we have all over h. Then what do we do here? Do not get stuck here, just a simple process. You factorize. So we factorize h, then we'll have 2x plus h. And then we will have x squared. And then we're going to have what? We're going to have that. Then what we do here, of course, we have limit as h tends towards 0, right? And we have limit as h tends towards 0 again. All right, so now this and this will obviously cancel, but let me use the tipping times method just in case some people might get confused. So we have 2x plus h all over x squared, then we have x plus h squared. Then this is the same as h over 1, so that we have a fraction divided by another fraction. Then this will become multiplication by 1 over h. Okay, fine, I don't know the way I wrote it. Okay, this, the first fraction, this is actually h. Then we have 2x plus h. I'm just rewriting the same thing, but I changed the division sign into multiplication and I switched this. So then this and this will cancel, and then we'll be left with 2x plus h all over x squared, then x plus h all squared. So what do we do in this step? So still we have limit as h tends towards 0, right? So now we have to substitute 0. So when we substitute 0, what we'll be left with, we substitute 0 here and here. So now we're going to have, let me just come to that step. Let's substitute 0. So when we substitute 0, we'll have, it's not a must to show the substitution by 0. This is just for some students who might not see the answer straight away. So I substituted 0. So of course this just remains 2x. This is 0, right? So now this is going to end up being x squared. X squared times x squared is x to the 4th. So that's what we have with x to the 4th. Now looking at this, using laws of exponents, notice we have an invisible 1, right? So whenever we have the bases the same, we subtract the exponents. So 1 minus 4 is negative 3. So if it's a negative 3, if we have this stuff, whatever is negative just has to go down, so it becomes x cubed. Or you can use this method where we say, here there is 4 of them, here there's only 1 of them, so this we cancel with 1 of them, so it leaves 3. So we're going to be left with 2 over x cubed. So that's our final answer. And any questions or any videos you want me to make, please comment below. And if you like the video, don't forget to just click the thumbs up and subscribe to my channel so that you can receive more of this type of things. See you on the next video.